Hello everybody, today I'm going to be talking about Apache Flume as a distributed, reliable and available system to collect log data. Uh, and my name is Maheshwar Dattatri and I'm doing this as a final project for the Big Data Analytics project program at Harvard University Extension School. High level, I'm going to be talking about in this presentation and overall the project, give you an overview of what Apache Flume is and how can we actually collect all this data efficiently. I'll also have cover some examples around high availability, reliability, and distributed architecture and how I implemented them. So just a quick background, Apache Flume, it's an open source Apache project. It's used for streaming data in a big data ecosystem. Typical use case is around collecting log data and moving them to other ecosystems, right? It was first introduced in 2011 in the Cloudera ecosystem, CDH3, and then it became a Flume NG when it moved into the Apache ecosystem. Newer Flume projects basically emphasized on simplifying configuration. It's basically, it used to be very complex configuration. It's now a single disk based configuration file. Also, kind of built in asynchronous design is a major change right now with the newer version. So that way the downstream and the upstream, right, the input and output tasks are handled by different threads, and in a way these don't affect each other. So the key components to Flume are there is a source, there is a channel, there is a sink, there is an agent, and there are events. So now, the inputs are obviously called source, and the outputs are called sinks, and the channel is the medium how you communicate the data back from source and sink. And agent kind of is a framework that runs all of this, and events are like you can think of them as a payload of data that gets transmitted through the architecture. Simple representation conveys the meaning here. You collect data from like weblog, web servers, and then move it to source, channel, sink, and then eventually into like a sink called HDFS. There are different types of sources that are possible here. One is like, Avro could be a source. You can set up spool directories. Where if data constantly comes in, then, or you can basically tail a file, constantly look for updates and keep getting the data in. You can also have HTTP as an input source. You can even set up JMS queues as an input source. There are other combinations that are possible too, but these are the more popular ones. In terms of sync, where the data can be written to, it's again Avro is a basic is the one that's mostly supported, and then there is HDFS location. Another major area is you can write it to like search in like Solar. You can write it to databases like HBase, and you can also basically write it to Kafka. Now, in terms of channels, I would say typically file-based is more reliable and robust. It offers you a quick recovery, but memory tends to be more faster, but it offers you less reliability in terms of recoverability options. And in a way, Kafka can act as that middle layer too that can host this data. A project that I did here, kind of implementing the whole idea just to start with, was I collected web server logs from Hue. So I did this project on the Cloudera Quick Start VM on my laptop. The use case was like, hey, as we browse through the Hue page, it's going to be generating web server logs, right? There's a web server running. So if we can constantly poll for it and then kind of push it into the spool directory, and then from there get it to like a HDFS location via a file-based channel. I thought this will be a good simple way to demonstrate the overall capability. But one thing you may want to be doing is you don't want to basically change the files a lot in the actual web server log directory, right? So kind of put in like a spooling directory is a way, as you can see here, you can get data from an application, like, it's constantly stored in a log directory. And then I can run an application called log rotate, which is like a commonly available tool on Linux, and I can pull the data into spool directory, and then eventually I can bring it into like a source for spooling directory. A quick implementation, you can actually run it through cron. So I've attached a screenshot of the code here. As you can see here, I'm kind of looking at the Hughes access logs, and I'm rotating. If the file size is less than more than 0, then I know I need to go and get the data, and I move it to a sync folder, and name it as access.log, and then I give the right ownership, and then move it with the right timestamp. So then it's available in the sync, and it is ready to be consumed by the downstream like Flume. It's kind of set this to run every minute. So the cron job, so it kind of keeps running. So we can see a quick demo of that. So as you can see, this is a sync folder. There is nothing in here. So I can go to like Hue. I can basically click a couple of things. So that means there's data collected. Then I can go and to so as you can see, the log file got recorded in here into the same place. So kind of proves that like it was nothing was there as I did everything. Kind of came the data came in here. Once we have data collected constantly, something of a polling setup to get it into a sync folder, you can keep monitoring the file, the cron file for this one, and you can see that it kind of constantly updating, so you know something is running. One of the major things around configuration is the conf file. So what we do is I put in a bunch of things. So I'll go through this conf file here. So you can define like source, sinks, and channels. And so in this case, I define the channel as like a file that we talked about. You define like capacity, transaction capacity, kind of gives you an indication of how much you can go back and store if the process fails, if you want to recover, how far you can go, how many messages, right, or how many messages that your channel can handle. This the source, again, a queue source, we putting it as a spool directory in the appropriate location, and then the sync more as an HDFS, putting the right path and like the prefix and suffix, and again we also do the rolling size, right? So uh, so for example, we rotate every 30 seconds. So if we set the interval to 30, or if you want to do it like every 10 events, you want to rotate and push them in. It's another way to do it. Or you could look for a certain size and then move the data in. So in this case, I'm not putting anything for like the size or the count. I'm just looking for every 30 seconds and then moving the data across to the HDFS sync. And in a way you collect the channel to the sync, and connect the channel to also the source, so kind of acts as an end-to-end flow here. uh, Let me do a quick demonstration of this. So now that we have data in Flume Sync, so let me actually, before I go there, so let me look at the target, right? I deleted, as you can see, the data in here. So there is actually no data in Hadoop HDFS location. So what I do is I go in here, I kind of run the Flume command. As you can see, -f kind of is the option to give the actual conf file configuration file, and then the n is the agent -n, so which kind of binds everything into one single workflow. So as I run this, so it starts loading everything. It bunch of logs. So as you can see that it's basically creating the stem file first. So what it does is it first goes to the directory and says, hey, I completed this action, right? It marked it as complete. So when it actually moved the data into like a channel, so the channel, as you can see, it as you can see, it's created 318. 318 is the local Pacific time right now. Uh, so as you can see, it kind of moved the data in. So let me do like a HDFS list. Earlier nothing was there, and now you can see everything is there. So you can see the process is fairly very quick. The big file got moved in fairly quickly. So let me stop this process here. Uh, I've attached some screenshots here, and so in case you didn't pay attention to the demo there. I talked about the Flume command that we already had, and also the web server logs that we used. Now, in terms of like other implementations, so we can actually have multiple sources run here. So what are the implementations that I have in this presentation? So how to be able to run them in parallel, right? That was one of the other implementations that I'll talk about. Also wanted to, like, it's a common thing, right? There could be sinks which could go down, your target location could go down, but you still want to be able to keep collecting. So I'll show a simple scenario where how we are able to recover. I will simulate a failure and how we are able to recover from the failure. And also in like I have another example of how we can actually add some reliability by adding some high availability and backup. So that's what I have here. So in this case, the first example, so I put in both the logs. In this case, first we looked at Hue, then I actually have the solar logs as well. So we have both the sources, because you said we can have put it in this case, I'm putting it all in one channel. And then so it can go to one sink here. So, but you can always have multiple channels going to multiple sinks. So as you can see here, I have multiple sources, solar source and view source, and define the directory where I need to be looking for, and kind of going and looking at all of these things here. Uh, Let me do a quick demo here. So out here, let me first go to Hue and connect and, like, get some data in here. At the same time, I'll also go to Solar, kind of do some activity here. So I'm doing all these things, so it kind of generates some files, right? So if we go back here, let's give this a minute to, like, populate in here. So that's what exactly I'm doing. I'm basically adding those, and I'm also, what I'm doing is I'm actually adding another axis rotate kind of thing for, like, the same way we did it for the other one. So I'm kind of adding the rotate thing for this one too, and then having it run constantly through a cron job. So uh, kind of let me so you can see here, let me go and look at the screenshot. So as you can see, the Flume sinks came in, and same thing I think we would have had in here. So let me I already started this process of, like, a different thing where we had multiple Flume things. So let me go and, like, keep looking for the files here. So already the one that we had from the Flume data, which is more so from the other side, is already copied in here. So yep. So this is a way we can kind of prove that we are able to write, like, as you can see, the solar sync data did come in here, and we're able to connect to multiple sources, and we're able to, like, pull the data in here. While we going through the presentation here, the same thing we have. In terms of failure and recovery, right? So what we're having is, if we had a failure with one of the systems like sync, then how do our process go and automatically recover from it, right? That's what I'm trying to prove here. So what we did is, I kind of basically made a simulation where as you can see from this slide, so I marked one of the this thing as junk. As you can see here, the sink is junk, and so as the process kind of goes on, so what happens is, the data keeps running, and then as the data keeps writing to it, the HDFS directory, as you can see, is empty. So when we kind of go and, like, do the same process in here, it gets loaded into the channel. So then when future, when we are able to go and fix it properly to, like, the proper channel, the sync, then what happens is it kind of takes in from where the checkpoint was left, and it takes in and puts the data into the location. So you can see the Hadoop location. Another important aspect that I would like to cover is the failover thing. it's a failover thing. And as you can see, I can have an HDFS and HDFS backup. So the main concept is we implement something called as sync groups, and we put multiple syncs in here and set priorities, and that way you can go and run it. So in this case, I set sync 1 to high priority. It took the data and put it in only there. If it was not there, it would have gone to sync 2. That's all I have. These are the references, and thank you so much for